Hey, this is 6.5. We're looking at the big idea here of graphing and understanding square root and cube root functions. Now, one of the first things we have to do is we have to talk about the basic parent function and what the domain is. For square roots, let's say you have function f of x underneath a square root. F of x needs to be greater than or equal to 0. You now know from your studies in chapter 4 what happens when you have a negative underneath a square root. We are graphing it on the real number plane. You have to have real numbers. You can't have a negative underneath the root. We don't care about anything outside, only underneath the root. The domain of a cube root, though, is all real numbers. We don't have that limitation for cube roots. So you can take the cube root of negatives, you can take the cube root of positives, because those do not give us irrationals. You can take negative 2 to the third, and you will get negative 8. So by that account, you can go backwards on the cube root of negative 8 is negative 2. What do these graphs look like? For this one, very important for the first one, it starts at 0. We've got 0, 0. And then we kind of just pick and choose nice numbers along the way. Looks like this is going by threes here. So what's another nice cube? Well, 1 is a nice one. So nice perfect squares. Square root of 1 is 1. The square root of 4. So we'll go over 4 is 2. You know, we can keep going here. The square root of 9 looks like right on that line. The square root of 16, and keep going on here, would be 4. But really it kind of grows slower and slower as we go. It starts to level off. It doesn't obviously ever level off, but these perfect squares get further and further apart. And so it doesn't grow quite as rapidly as it does in the beginning. Cube root, on the other hand, does go in both directions, and it follows similarly, but cube roots just are a little bit slower to grow. So obviously the cube root of 0 we know is 0, so we'll have that coordinate 0, 0 here. The cube root of 1 is positive 1, so over 1, up 1. The next one, though, is the cube root of 8. So you have to go all the way over to 8 just to get up to 2. And then the cube root of 27 is 3. So we got to go all the way to 27 just to get to 3. And so it's growing, but again, slowly, and it's really starting to level off the further and further you go right. Now, the same can be said about the negatives, though. Now, there's no negative 0, but the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. And so it's a mirror image, essentially, on the other side. Negative 2 is negative 8, and then negative 27 would be negative 3. And so it looks like this. Arrows on both sides. Kind of a elongated S, in a way, stretched from left to right. Okay, so those are your two parent functions. Very important to understand the domain. With root functions, you have the same translations we've been working with throughout all year. We started with absolute values. We called this the vertex, h and k. So you had a absolute value, and that value was h comma k, right? If you remember that graph. This is literally called vertex form for a parabola. And remember, h and k represented, if we have a parabola, say it looks something like this, the bottommost point right there was h comma k. We don't call it the vertex for a root function, but it's that important point for the square root. It's where it starts, and for a cube root, it's that inflection point, that twist point. So the big idea here, in order to graph something, you are not going to worry about the transformations. You are just going to simply graph the function y equals a times the square root of x. And so, this is more of if you're graphing by hand. Obviously, we have decimals now, so we're not going to have to do too much in the way of graphing, but we do want to have a basic understanding. We want to start with this function, and then we'll understand what h does and what k does. So I'm going to switch over to decimals, and I'm going to just put in some sliders and just kind of show what these things look like on a function. So let's start with a square root. Y equals, if I put a as a slider, square root of x minus h, and then get out of the square root and plus k. So we'll make all of those sliders. Now a is 1, that's my parent function. So a has to be 1, but if we move h back to 0, and we move k back to 0, there's your parent function. So you can see that it grows, fairly slowly as you go further out. Okay, and there's nothing to the left. So now h is inside, that shifts it to the right and left. So if I move that to the right, and then I move it to the left, there's what h does. And then the same thing with k, shifts it up and down. Now notice that h controls the domain. If you go to the left, it's not to say that you can't put negatives. If you make h -10, -10 is part of the domain then. You can plug -10 in. So it's all about 8. K does not change the domain. That shifts it up and down, but it does not change what values you can put into the function. So we're going to go through a basic guideline of how to graph, but you can use decimals on most of these questions. So here's how we would do it. If you're asked to graph something like this, let's just understand what's going on in this. We know that this is shifted to the right 2. So even though there's a negative there, that'd say x minus positive 2, and it's been shifted up 3. So the first thing I always like to talk about is the domain. I look at my inside stuff, x minus 2, that needs to be greater than or equal to 0. Add 2 to both sides, x needs to be greater than or equal to 2. So our domain is going to start at 2, and that's it. Our important point, h comma k, is happening at 2 comma 3. It's kind of the starting spot for this square root function. Starts right there, 2 comma 3. From there, we'll be able to graph this, but it's hard to kind of plug things in. So what I like to do is plug in your original function and then shift that to your new space. So we're going to graph this. We're going to graph y equals 2 times the square root of x. And there's predictable x values we use. The square root of 0 I know, the square root of 1, the square root of 4, the square root of 9. We can go even to the square root of 16. So when we plug in 0 to this, it's the square root of 0. So 2 times the square root of 0, well, that's just 0. So I'm going to put that point in. I'll put it in pink because we are going to translate that in a second. Keep going down the list. 2 times the square root of 1 is 2. So I would put the coordinate 1 comma 2 over 1 up 2 right there. If you plug in 4, you would get out 2 times the square root of 4, which is 2 times 2. You get 4. So 4 comma 4. Finally, 9. You can start doing this pretty quickly. Is 6. 2 times 3. So over 9 up 6. And 16 looks like we might be off our graph, though we could evaluate 2 times the square root of 16 is 8, and I'm off my graph. Okay, so we've got this kind of starting graph here, and we're just going to translate every point. Translate every point up 3 and to the right 2. Now we know that starting at my first value, this one goes up 3 over 2 to that point. And we go up 1, 2, 3 over 1, 2. We would have a new value there. Do the same thing with my next one, up 1, 2, 3 over 1, 2. Have a new value right there. And so our graph starts to look like that. And eventually you can kind of clean up and get rid of, though you don't really need to, but that is our translated graph. You can do the same thing with cube root functions. Cube roots, we're just going to ignore. We know that that 3 means it's to the left 3 and then down 2. So what are good cube root functions? Well, you've got -8, -1, 0, 1, -8. It's a good place to start. And we're going to graph y equals -2 times the cube root of x. So when you plug it in here, you get -2 times 2 is going to be +4. When you plug -1 in, the cube root of -1 is -1. -1 times 2 is 2. You're going to get 0 here, +1, and then multiply by a -2, and then that's a that's not supposed to be -8, excuse me. +2 multiplied by a -2 is -4. So you plot those coordinates. 0, 0, let's see, over 1, down 2, back 1, up 2. They're symmetrical, so you can kind of do both at the same time. Over 8, down 4, 8, down 4, and back 8, up 4. We could go one more, 27. Looks like we would have enough room, but you get the idea. Now the translation, we just move each of those points, left 3, down 2. So you go over 1, 2, 3, down 1, 2. Moving over 1, 2, 3, down 1, 2. Point there. Over 1, 2, 3, down 2. 3, down 2. 3, down 2. And just making a smooth curve with that. So just a little reminder about your translations. You can use Desmos to help you graph these, of course, but just wanted to show you quickly how to translate them. You've got a short homework assignment here.